Welcome to the manufacturing process. This is Professor Venkatachalapathi, Institute of Aeronautical Engineering. So I would like to discuss about rolling process. In the manufacturing process, so far I have discussed the basic casting process and secondary process, welding process or fabrication process. Third important unit where we can known as metal forming or metalworking process. So in the metal forming or metalworking process, generally where the plastic deformation takes place by the application of repeated blows, we can able to desired shape and size can be formed. That is called metal forming process. In the metal forming process, generally that wastage of material is negligible. So wastage of material is negligible. That is, whatever amount of raw material will be taken into the consideration, the same amount of can be utilized properly, so that the wastage can be negligible. If very least matter, that some flash also that can be very little bit amount will be there, that can be easily removed by a simple process. I would like to tell about in this metal forming process, rolling is the one of the important hot rolling and cold rolling process. So let us discuss about in the hot rolling process. So before going to discuss about hot rolling process, let us see how the rolling process can be performed and what different type of rolling process, what is the advantages and limitations of the rolling process, and how the application of rolling process where you can billet form into some small ingot and small square and circular rod can be obtained. So let us see a simple rolling process can be explained in the flow diagram. This is a diagrammatic representation of rolling process. So I hope in this diagram you can see the direction of feed. The workpiece can be fed in between two rollers. One is the upper roller. This is called upper roller, and bottom roller. So in between there will be one workpiece. Whenever by application of the pressure, that is a compressive force and shear force, so that the reduction of diameter can be reduced, length can be increased. Okay, so this is initial. So this is starting thickness T1 and final thickness T2. How the transformation of original thickness to a final thickness. So where in this rolling process there will be two rollers. One is the bottom roller and upper roller, and both will be, the direction is in opposite direction. One roller will be in a clockwise, other roller will be in anti-clockwise direction, so that the material can be elongate as per the compressive force, and at the same time some you can able to have some shear forces also. So let us see the basic definition of hot rolling process. As we have discussed earlier, the hot working process, the term hot working process can be defined as it is the process of heating the metals above its recrystallization temperature. Yes or no? Hot working means the heating the metal above its recrystallization temperature, you can call it as hot rolling process. Similarly, when you are discussing about cold rolling process, means below its recrystallization temperature, or it can be done at the room temperature. Okay, so that is the basic difference between a hot working and cold working process. As in the hot working process, generally the first and foremost application of hot working is a hot rolling process. Yes or no? So wherever the steel rods and some of the ingots to a billets, and billets to some small square rods can be made from this hot rolling process. It is a sequence of process. Continuous passes can be done in a hot rolling. Even one pass cannot able to form even a small thickness also. It is able to change the thickness. It will take several type of passes. More than 5 or 10 and 20 passes you can convert. Square will become a circular. So for example, if you take the one square rod, how we will convert into a circular rod? So by applying the pressure or force, compressive force, and with the number of passes. Okay, so let us see the definition of a hot rolling process. Hot rolling is a metal working process. Look at, hot rolling is a metal working process in which the metal is heated above its recrystallization temperature. That is what the term recrystallization can be defined as the process of changing old nuclei into a new nuclei. So that is the grain structure can be elongated and extended. Again, it will be discontinued with the small grains, and that is why the changes of the old nuclei into a new nuclei is called the recrystallization. The temperature at which recrystallization takes place, we can call it as a recrystallization temperature. Where in the case of hot rolling process, in this metal is heated above its recrystallization temperature and to perform plastic deformation in the working of rolling operation. So this process is used to create the shapes such as some desired geometries, dimensions, and some of the material properties while machining or maintaining the same volume to the metal. So especially here, this is what first this square, again it will be tilted into a rectangle, again it may be formed into a this vertical, and some shape can be obtained, and similarly like that some different shape forms can be obtained, and so that various type of passes to be obtained, and so that finally the circular rod, there is a number of, even you can see 1 2 3 4 5 6 7 8 9, still more process, just with the space consistency I have not covered more thing, but as for the transformation of thickness, a square rod into a circular rod, always you should be able to provide the workpiece in between the two rollers. One is the bottom roller, other one is the upper roller. The both rollers will be rotate in opposite direction. One is clockwise and other is anti-clockwise direction. The two forces, one is the compressive force and shear force, can be applied so that it will be changing the thickness T1 to T2. So this is what about hot rolling. This workpiece also, it will be in a red heated condition. So once it can be heated, you can able to kept through cranes and some equipments where it is difficult to handle a human being. You can use the some equipments, transfer of the raw material into fix in the two rollers. Okay, and whenever the hot metal is passed in between the two rollers to flatten it, so and lengthen it. So this is what, to flatten it, lengthen it, reduce the cross sectional area to obtain the uniform thickness. This is the general definition. So because hot metal, it is difficult to handle a human being. That is why we have to take the some of the machines, some cranes to be taken into the consideration to can feed in between the rollers, so that the two rollers, when you hot metal is passed in between the two rollers, and so that it can be flattened and lengthen it and reduce the cross section area by repeated with the uniform thickness, can be number of passes can be increased. Initially it is a rectangle and square, again rectangle, square, and some elliptical shape, and that you can like that you can apply pressure and tilt it, again apply. So like that various changes of it, the shape and size can be obtained. Finally, whatever required, a square to be formed in a circular shape. So this is what a hot rolling process. In general, the materials also steels and some of the cast iron, some ferrous metals also can be widely used to convert into this type of steels, especially for the construction field, that steels, okay. Steels also made up of this rolling process, and some of the ceramics pipes also can be made this hot rolling process. And majorly it can be widely used in a metal industry because the end product should be a raw material for subsequent operations. It is very difficult to change the one shape in a one pass. Automatically it required a number of passes so that you can able to perform changes the original thickness to a final thickness. This is the a general principle involved in the hot rolling process. Next, coming to the different types of rolling mills, we have discussed the general concept of the hot rolling process. Whatever the given input, with the application of compressive force and shear force, it can be able to change its shape. That is called the basic principle of rolling. And when in the case of hot rolling means heating the metal to above its recrystallized temperature. Heating the metal above its recrystalline temperature, you can call it as a hot rolling process, where again depending upon the usage and number of rolling mills can be used, there are number of classification will be known. So the first and foremost thing is 2 high roll mills, 3 high roll mills, 4 high roll mills, cluster roll mills, planetary rolling mills. Like that, number of rolling mills will be there. Wherever the usage, the changes of the cross section and changes of the shape and size with the multiple passes that we can do with the help of the different type of rolling mills only. So let us see first this diagram. This you can see the 2 high rolling mills only previous. This is called 2 high rolling mills. So where one upper roller, one bottom roller, in between the workpiece will fed in these 2 rollers, and whenever to flatten it, lengthen it and reduce its cross sectional area, and to obtain the uniform thickness, which is called the 2 high roll mill. So suppose if you add one more rolling mill, that is called 3 high roll mill. You can see the first initially you can do the first, this is the first pass. Again it will convert into the second pass. Okay, so there are 2 passes can be obtained in this 3 high roll mills. So 3 rolling mills can be used. One is the bottom and top, in between one more roller will be there. The first pass, so first direction of it workpiece, and this is these 2 rollers are opposite direction. Again this roller opposite to the central roller. So that is why. So first initially you can feed the first here, you can reduce the cross section, and second it will come back and the thickness can be still reduced. Okay, so this is what about the how we can able to obtain the workpiece reduction with the 3 high rolling mills. In the 2 high rolling mills, only 2 rollers, whatever amount, a simple shape of size can be easily eliminated. Here again it can be tilted first pass and it will enter to the second roller. So like that, more than 2 rollers we can call it as a 3 high rolling mills, or this is also we can call it as the multiple pass rolling machines. Okay, there are 2 passes can be used, 2 rollers can be used, 1 pass, the another 2. So 1 roller, central roller is common to the top and bottom rollers. Okay, so wherever you can feed in either this direction or this direction also. Okay, whatever the direction where the 2 rollers will be in opposite direction. Okay, and let us see the in a 3 high rolling mill, we can call it as a 3 high rolling mill. So all the 3 rolls are rotate in their bearings in the same direction. You can see the this will direct, and if it is in clockwise, this may be anti-clockwise. This will be clockwise, it is in anti-clockwise direction. But the advantage of this 3 high rolling mill is mainly the mill is that work material can be fed into the one direction between the first and second rolls, and return pass can be between second and third rolls. That is the only principle behind it, 3 high rolling mills. And this results in the transport of material from one side of the rollers to the other. So you can easily, no need to for a 2 high roll mill, only once you can fix it is a constant reduction of thickness can be done. But here first you can fed it automatically, it will go to the second pass also. So that is why it is some production rate can be increased in the 3 high roll mills compared to the 2 high roll mills. That is why this 3 high rolling mills results in the transport of material from one side to the other easily can be made. So this is what about the 3 high rolling mills. Now let us see another important thing is 4 high rolling mills. Look at this is the 4 high rolling mills diagram. So only difference between the 2 high rolling mill and 4 high rolling mills. In the 4 high rolling mills, in between there will be small rollers will be kept first. Above that, some backup rollers will be done. So here, in general, if you neglect these backup rolls, it will comes under the 2 high roll mill. Okay, so why you have to add the 2 more rollers above these rollers means to increase the compressive force, so that the amount of the thickness reduction can be increased. So that is why this is called the 4 high roll mills. It consisting of 2 small diameter working rolls. So we can call it as these 2 are working rolls, and the above 2 are backup rolls or pressure rolls. Backup rolls. So these are the backup rolls, and you can apply the pressure uniformly. But workpiece can be, it can kept in between the small working rolls, and whenever the small working rolls cannot able to reduce the thickness properly, so that you can apply some backup rolls in order to reduce the thickness effectively. And here the large number of backup rolls provided because necessary, and the backup roll cannot exceed the diameter of working rolls more than 2 to 3 times. This is what, okay. So whenever the backup roll cannot be exceed the diameter more than the 2 to, so if it is exceed the backup rolls, it is very difficult to compress. Even it may be damage also can be occurred. That is why only that backup rollers can be below 2 to 3 times of that working roll diameters can be used. Okay, and similarly in this cluster rolling mill. So cluster rolling mills, you can add another 2. It is a 6 type of roll mills. So we can simply call it as a cluster rolling mill. So in this cluster rolling mill, you can see the 4 high rolling mill is 4 horizontal rolls and 2 small diameter. So 2 is larger, that is called backup rolls, and 2 larger holes are called as a backup rolls. Small rolls in the working rolls, but they would be thicker in the center, thinner at the end. So this is what the only basic difference between a 4 high and a cluster rolling mills. In the cluster rolling mill, you can add another 2 rollers in order to maintain the uniform thickness. You can vary the uniform. This working roll cannot deviate. So if you kept one, sometimes due to vibration, there is a changing of the thickness, uneven thickness can be obtained. But here, if you fix it on both, that roller cannot move left and right, so that exact uniform finishing also can be made in this cluster roll. The cluster roll only that backup rolls diameter always should not exceed the 2 to 3 times of the working rolls. But when in the case of 4 high means you can able to use the large size. Too much large also can able to do it here. But in the case of cluster, only less than 2 to 3 times of that working size roller can be used. Here you can see inside one roller. So the first roller, it is clockwise, means the remaining backup roller which will be in opposite direction. So that is the only difference. So for example, small roller which is in clockwise direction, obviously the other 2 rollers will be in opposite direction. Okay. So here also you can see one roller, it is in clockwise, and here it will be opposite direction. Okay, so that uniform thickness can be easily eliminated, and with the here only one pass. If it is a 3 high roll mill, there is a 2 pass will be there, but here in order to reduce the maximum thickness, you can prefer for the 4 high and cluster type of rolling mills. Now let us see the another interesting rolling mill, which call it as a multiple rolls. If keep on using multiple roll also. Okay, here you can see the like a cluster. Here also some 6 rolls are there. So how the thickness can be reduced uniformly. Here some thickness can be reduced and some tapered. It is going to be reduced with this thickness, and slowly here the original thickness. This is the original thickness T1, and how finally it will transform into a T2. And this is also called planetary or a tandem roll mill. We can also call it as a multiple or tandem mill type of rolling mills. So this includes mainly the number of non-reversing two high roll mills. So which provide one after the other. So easily you can apply the compressive force parallelly so that the small type of reduction can be applied. Like you can see in this pen also how much effort. This also can be done. First roller you can put and put the backup roller so that the thickness based on the applying of the compressive force it can be done slowly, and finally whatever existent of the thickness can be obtained, they can able to do it. And here one more thing, the material can be passed through them in order one by one. Slowly you can apply the raw material so that you can able to reduction can be easily made. So otherwise if you do it fast means the total overall thickness cannot be reduced. So this multiple rolling mills only suitable for the mass production work. So where in the case of two high roll mill, in this case only if you produce for the one two or three rods in a 5 to 10 minutes, but here in this case a large more production rate, it is complete rotation will be taken into the consideration. So instead of two high roll mill, here about 2 to 3 time of reduction can be taken, and more size can be removed in this planetary or multiple rolling mill or tandem type of mill type. Okay, so it is a very quicker change of the setup, and this will consume a lot of labor work, because to keep the rollers above the working rollers, these also backup rollers and supporting rollers also can call. So this is called the working rolls, and this is called the backup roll or supporting roll. You can also call this supporting roll. This is the workpiece. Workpiece will enter into the small working rolls, and to apply more pressure by compressive force, you can add some more rollers also in order to maintain the smooth finishing and smooth reduction takes. It is a production rate will be very very high, because of this method is most widely suitable for the mass production. So this is what about the rolling mills. So in general, as I discussed earlier, a simple rolling process, hot rolling, cold rolling. When you use the hot metal, it is called hot rolling process. When you use the metal at room temperature, so that metal directly can apply, you can apply lot of pressure should be taken. But when metal is heated, even if you apply little pressure also, it can able to change and shape. But in the case of cool metal or some the metal which is not heated, it is when you wanted to change in small thickness also, you can apply lot of pressure should be applied. That is why that is the one disadvantage in the cold working process. Lot of force can be required whenever you wanted to apply lot of force, and lot of sometimes pressing machines also can be taken into the consideration to change the thickness. So that is why in a cold working process it is only single process, only pressure tonnage will be more. Okay, but initial cost only high, but for the compensation of the cost under production rate can be more. And but in the hot rolling process, there are heating can be done. Again, this transfer forming can be done with the application of the pressure, that is a compressive force, and shear force can be obtained. And coming to this final types of rolling mills, two high rolling mill and three high rolling mills. In two high rolling mills, only two high roll mills are used. Three high rolling mills, another rolling central roller can be added, or intermediate roller can be added to change the two passes. First pass and second in the second pass. So whatever the reduction, suppose it is 10 mm thickness, can be reduced by 8 mm. Again 8 mm will be entered into it will come the 6 mm. Again you can use the third pass also, but if you fixing of the multiple rolls under, it is difficult to attachment is somewhat difficult. So that is why in these three high roll mills, only transport of the material from one side of the rollers to each other, it can be easily. If you move so large metal means some defects also may be occur. So this is what about the 3 high. And coming to the 4 high and cluster mill, the only difference between the 4 high and cluster mill means in the 4 high mill, it is vertically, the rollers will be kept to one working roll. Above that working roll, we can add this backup roll. But whereas in the cluster, parallelly, the backup rolls will be kept in between that working roll. But 4 high roll means it is vertically above, we can able to keep. But in the 4 high rolling mill, only smaller rolls are the working rolls, but the would be thicker than the center and thinner at the end. Okay, at the end will be very thinner to be used. But when in the case of cluster rolling mill, there are also small rollers, and above that 4 or more backup rolls can be used. So the large number of backup rolls, the size cannot be exceed the diameter of the working rolls by 2 to 3 times of its diameter. So that uniform reduction thickness can be made in this cluster type. And this multiple or planetary or tandem type of mill is used for mass production, and wherever the lower volumes require quicker change of the setup, and it will consume a lot of labor and work should be introduced in this multiple roller tandem roll mill type. So this is what about the hot rolling process. But cold rolling also, only the metal cannot be heated, it can be at the room temperature, but pressure can be applied little bit double the pressure where in the case of hot rolling process. Okay, so this is what about the classification of the rolling mills. So in the next session, we would like to discuss about the metal forming in the case of extrusion. So in the next class, I'm going to discuss about the extrusion and types of extrusion. Before going to tell about that, just I will give a brief idea what is extrusion, how the three-dimensional analyzation of the extrusion, and how the classification of extrusion, it is a direct or indirect, and what type of material to be used, what type of pressure, how much tonnage of press can be used, and what different type of materials use a different type of temperature. Okay, so this is what you can see. This diagram, it is a self-explanatory. It is called a direct extrusion. So whenever the workpiece in the same size, this come out also same direction. Whenever by keeping the workpiece and by apply the pressure through ramp, and this is a billet form, and the final product can be reduced. Okay, so there will be a container and the die should be kept. The opening of the die only, what are the shape we can able to obtain that thickness. But in the case of indirect means other side it will be closed. There will be closed die, and when you apply and material come this the opposite direction. What are the material apply inside, the material come out in the opposite direction. That is why it was an indirect extrusion. Okay, and in the hot extrusion, it is also comes under the metal working process or mechanical working of the metals. In this case also, effective amount of raw material can be utilized. Here also the negligible wastage of the material. So whatever the amount we can keep inside, the same amount can, there is no wastage occur in this hot extrusion also. Even the term hot extrusion also can be defined as, it is also heating the metals, either ferrous or non-ferrous metal, heating above its recrystallization temperature. We can call it as a hot extrusion process. When you're speaking about the cold extrusion or impact extrusion, heating the metal at the room temperature, but by applying the pressure or force to changing of its shape, that much pressure only can apply. Simple thing, the metals such as lead, copper, aluminum, magnesium, they are having the low yield strength mechanical properties, and wherever the extrusion temperature, so that they are hot extruded process. So this hot extrusion generally it may be most widely used in hydraulic operated. Sometimes pneumatic presses also can be used. Most widely hydraulic operated machines are used because of hydraulic means some lubrication also can be done due to high pressure. If you're having the lubrication, the easy changes of the shape can be obtained. But here the lot of pressure tons also, it can be vary 250 to 5500 tons capacity used to reduction of the change of the shape and size. Okay, and most widely used material is steel, and whenever the steel also can be changed, is transformed in the high temperature only. Okay, so this is what about the hot extrusion. This diagram itself self extrusion, and this is also called the direct extrusion. Direct extrusion. So in the direct extrusion, you can see this is the billet or raw material, and initially you can keep inside the mold or die, and output can be come out in the small opening called the die. Okay, and where it is in red color, the force applied through ram operated machine, and by applying the force due to tonnage. Okay, how much tonnage required to change it, the shape, that much ton only can be preferred. Most probably the size can be rated from 250 to 5500 tons to be operated by changing the reduction. Even it can be heated, even some less tonnage of pressure also can be preferred by changing its shape. And most widely used material is steel, and it can be extruded at very high temperature. Okay, so this is what about the extrusion process. And this forward extrusion means you can see the whatever the raw material inside this side, raw material, and metal, extruded metal is outside. Raw material enter inside, extruded metal coming out of inside that cylinder. Whatever the changes if the crystalline structure of changing of the old nuclei into new nuclei when it is in the temperature, recreate temperature above its recreate temperature, called as a hot working process, where you can see the hot working or hot extrusion process, heating the metal above its recrystallization temperature. And coming to these advantages of the extrusion, generally where low force required to compare to cold working. Obviously, I told when it is heating, very less force is used. Whereas in the case of cold working process, there is no heating can be done. Obviously, a lot of pressure and force is required to change its shape and size, and easy to work in hot form. So in the hot extrusion process, expert people will be there. You can easily work with the hot form, and the product is free from the stain hardening. So that is what almost all when the heating can be done, it will eliminate oxides, and some voids can be removed by heating. Then by applying the little pressure only, you can obtain the reasonable and required shape and size can be formed. For every process there will be limitations also is there. According to this extrusion, the low surface finish due to scale formation on the extrusion part. So why? Because always in extrusion process, surface finish some porous in nature like that may be obtained. That is why the low surface, because of the scale formation, that hot oxide particles will be entered into the surface. That wanted to remove means you can again one more finishing process can be introduced. And wherever the increased dye wear because of the water and some particles, dust particles, it will be wear. So when you wanted to use, then only you can clean, and you should put lubrication. Then only it will make good material. Dye should be very clean and effective, and maintenance cost is very high in this type of extrusion process. Either it may be direct or indirect process. Okay, so this is called forward or direct extrusion. And in the next class we will discuss about how we can able to define the indirect and some backward extrusion process. Okay, I hope all the students you can understand clearly. Even you can go and prefer manufacturing technology by P.N. Rao, or sometimes Ajara Chaudhary also is preferred for study all those metalworking or mechanical working of metals. Okay, this is what about the uh, hot rolling process and the types of rolling mills, that is 2 high, 3 high, and 4 high are cluster and planetary mills. Okay.
Like, share and subscribe. Hit the bell icon for more updates.